detail, we'll basically understand what this Kubernetes really is and how it relates with the container, then understand the basic architecture of the Kubernetes and explain two major components, that is master component and node component. Then we'll discuss about the Kubernetes pods, that's actual unit which Kubernetes runs, maintains, manages. Now to talk about the relationship between Kubernetes and container, before that, let's first go a bit into the history of the Kubernetes, how it all started. So Kubernetes is a Greek terminology. It stands for helmsman or pilot or the governor of a ship. Okay, so and it was founded by four people: Ville Aikos, Joe Beda, Brendan Burns, and Craig McLuckie. They were quickly joined by other Google engineers, including Brian Grant and Tim Hawkin. And it was first announced by Google in mid 2014. Its development and design are heavily influenced by Google's Borg system, and many of the top contributors of this project previously worked on Borg. So the original code name for Kubernetes within Google was Project 7. It is a reference to the Star Trek X Borg character 7 of 9. The 7 spokes on the wheel of the Kubernetes logo are a reference to that code name. So you know what Kubernetes really is, and then why the logo looks like that, and why the Kubernetes sometimes calls K8s. Now, Kubernetes is sometimes also known as K8s because between K and S there are 8 characters or 8 letters. So we sometimes start with capital K and then use the digit 8 and ends with S. Now, why we need Kubernetes? We have Docker, we have container, but why we need Kubernetes? Now, these are the problem which Kubernetes solves. It solves the problem of monitoring a container and then making sure when the container goes down, there is another waiting up and running. And because the container runs on top of an operating system or a machine, either it could be a virtual machine or a physical machine, it can also fail. So by default, container do not provide these kind of fault tolerant solution or high availability or reliability kind of solution. So, and we can, or in actual production scenario, we run multiple containers, not just one container. Now, what is the networking you need to do? And then how does you alter individual container and move them up and down? So for example, you have an application which is getting more requests and you want to increase. How do you do that? And then how do you network them? How do you connect them back to the backend system? So all these complexities with the networking, etc., are being also handled by Kubernetes. And then in the Kubernetes, as you can see that it can manage large amount of container in its own environment with certain capabilities built into beyond what you see in the container. So let's see what all it can do. Now, because it manages the containerized environment or the containerized workloads within its cluster, and also this is an open source technology. So Google has given this Kubernetes code base to the Cloud Native Foundation. Since then, the Cloud Native CNCF is maintaining and managing that Kubernetes code and then making sure that it is being patched, the securities are being handled, etc. This is also scalable and extensible because Kubernetes not only comes with certain interesting or useful features, but also if you think that some of the features you don't see over there, you can always extend them. And you can run Kubernetes in platform as a service, infrastructure as a service. You can even run your application directly over there, right? And it doesn't really change much whether you run Kubernetes on premises or in cloud. So with one expert understanding Kubernetes can manage the Kubernetes in any platform. So that's the flexibility Kubernetes also provides. Now, Kubernetes has got few characteristics. One of them is to manage the health of your deployed resources, right? It constantly probes into all the individual component it deploys and then make sure that they are up and running. And then it also does automation in terms of auto scale. So it basically increases or decreases the capacity whenever there is a demand required, right? So that capability is built in to the Kubernetes engine. Now, in terms of Kubernetes and container, as we all understand that Kubernetes is all about running container within that. So there is a bit relationship over there. What is that? Kubernetes itself manages certain clusters, machines, right? Where it basically puts the container and then makes sure that they are being distributed properly, maintained, and managed properly. It has a version control system to make sure, like if you have multiple deployments, you can always go back to the history of the deployment and then redo the whole thing back in the history. It also replicate the setup, which means that you can increase the capacity of the cluster and then attach them into your Kubernetes system, and it will basically be able to provide you more and more capacity. Now, thousands of container cannot be managed manually. That's quite obvious. And that's why we need some system. And that is why we have Kubernetes here. Now, if you look into the Kubernetes aspect of it, right, it basically controls the amount of compute each of these container-based application needs. What is the network distribution it requires? How does it store the resources in terms of, like, let's say one node goes down, it needs to rebuild whatever was there in that node into another node. How does it make sure the resources which are static in nature lives within the Kubernetes system and then being used when there is a need? It comes with a lot of flexibility in terms of command line interface, right? And then you can actually integrate that with your typical DevOps pipeline to help you automate the whole process of doing things through certain automation. So it has got great integration with other things. Now let's go a little bit deeper into Kubernetes architecture and try to understand how the components are being laid out. So you'll see this picture again and again in this presentation, which basically will try to go a bit deeper into each of these components, but understand this side where you have this area, right? And here you have that Kubernetes master component. And that's the key component. That's what everything resides. Now, this master component is a single component. It can be distributed across multiple machines, but to think about it as a single unit of component, right? And it has got a couple of things we'll talk about in detail a little later. But it also uses something which is in this right-hand side called nodes. So these are machines where actually your container is running. Okay, so you can start with one and you can increase this number of machines into hundreds of machines. And this Kubernetes master will keep adding these into its cluster and it will be able to maintain and manage, right? So that's what it looks like. Now, by default, the Kubernetes master is a single server deployment. Now you can distribute it. So you can put etcd in a different machine. So in a high scalable solution, right, you generally put things into multiple different machines and club them. So it also supports that multi-master configuration. So Kubernetes in a nutshell is a client server model. So you have a client that is node, set of clients, and then you have one single server that is Kubernetes server. And that's how it basically integrates internally within its component. Now, To understand the Kubernetes architecture bit more in detail, what we will do that we will understand where we run what, right? Now we start with Kubernetes, one master, one node, and that node will run your container. So whenever you say that you want to run an application, which is a containerized application, put it into Kubernetes, it runs on the node. And that master keeps monitoring that node. It is like running your container in the Docker runtime. So when you have a container image, you download that image to your local machine, you run it in your Docker runtime, and it runs that container. It is similar to that, but it gives you additional capability of maintaining, managing, and understanding the health and the traffic of your container based application. That is what you get additionally. Now, Kubernetes does not run container directly. That's what we need to first clear it up. So we don't say, hey, we have a container, go ahead and run the container in the Kubernetes. There is nothing like that. The smallest component of the Kubernetes is known as pod, P-O-D, pod. It can run one or more containers. So imagine that you have an application which has got three components. One is the app, another is service, that is API, another is database. You can have three containers separate, and then you can put them all in the same pod. In normal scenario, Kubernetes, a container actually can also have logging mechanism built into in a separate container. So you can club them together in a single pod and then run them also. So pod can run multiple containers. Now, what happens when you run multiple containers in a single pod is that it is now able to use the same resource and network. So each of the pod gets a network. So you can see that it gets an IP address assigned by the Kubernetes system, right? And it also has a shared storage for storing the files. And then it can actually communicate between the containers within the single pod without really worrying too much about the external things. So that could be one of the points where you can think of using multi-container pod, but you are okay to run only one single container. Now, when you deploy a pod into one of these nodes or ask Kubernetes to deploy your pod, which has a container in one of these nodes, it is actually controlled by the Kubernetes master, or sometimes we call them as control plane. Now let's understand this control plane a bit more, right? It can run across multiple machines. So when you have, let's say, three nodes in this case, you have three different machines, which is connected to this Kubernetes master. So it is basically allowing the Kubernetes master to be able to talk to each of these machines to understand how that machine is behaving. You can make it fault tolerant and highly available because it is the heart of the system. So if anything goes wrong in this Kubernetes master, everything will go down, nothing will work. You can actually strip down one node, that's fine. So as soon as there is an availability in other nodes, Kubernetes will make sure your pods are deployed. So it is not that critical when node goes down. But when the master goes down, everything goes down. It's the heart of the Kubernetes system. It's like a human body. So if heart fails, everything stops. Now the Kubernetes master component, let's go a bit deeper into the master component to understand what it consists of. So in this diagram, we have seen that there are a couple of components. So let's see what all these components really offers in the master components. So if we go inside that, we see that couple of things. Let's talk about them. So to begin with, we talk about etcd. So it is a database system. So we'll go a bit deeper into each of these components, but let's understand that it is a key value pair database system where Kubernetes stores anything and everything it needs to store to be able to run maintain things, right? And then the API server, also known as Kube API server, which can only talk to the etcd and retrieve the information or save the information. That's the only channel through which you can interact with etcd. No other component within the Kubernetes can interact with etcd. So you have to interact via the API server. And then there are two things comes like control manager and scheduler. So we'll talk about it in details in our upcoming slides. So let's go deeper into that. Now to understand etcd, right? You see that first of all, it is a database, right? So it stores data in key value pair. That's the basic thing. And then comes to this thing like, what is this etcd is about? It is actually a highly available key value store, which Kubernetes uses to back it all cluster related data. You should actually have a backup plan built into for the etcd. So just in case if anything goes wrong with etcd, it's corrupted, it basically can recover from it. Now it's open source technology, right? Uh, in the Unix or Linux kind of operating system, you have a /etc directory, right? So it basically refers to that name. And it's a secure storage. So everything is encrypted. So you can't really read anything, even if you have access to. It runs on operating system like Linux, macOS, etc. So etcd can also be used independent of the Kubernetes. So it is an open source key value pair data store mechanism. So it is not just only for Kubernetes, but also you can use it independently. Now, if you think about the etcd, right? If your Kubernetes is a massive cluster, right, and it has got many nodes and many pods in a kind of large public cloud scenario where you provide service within your Kubernetes, right? You can distribute that etcd into multiple blocks, right? And then you can actually synchronize the data across multiple etcd. So if, let's say, one goes down, another is up and running. So that is why this core database can be distributed and put across into multiple geographies also if you wish to really make it happen that way. In terms of the etcd, right, the backup plan, it is key to the Kubernetes management. So if you, let's say, manage the Kubernetes by yourself, you need to have a backup plan or backup mechanism built into the system. You can also understand what exactly is happening in the etcd through webhook. So by leveraging the capability etcd offers, you will be able to understand things happening inside etcd. Now, coming to the master components, another key component that is Kube API server or API server, sometimes we call it like that. The Kube API server is an API server component of Kubernetes control plane, which exposes the Kubernetes API. So all you need to do to create a pod, to delete a pod, to, let's say, scale it up, scale it down, all these are API calls. But you're not calling any REST API or you are not doing anything. So there'll be an abstraction created on top of that API given to you via CLI or any other means, and then you can just send that information to the API, and API will then interact with the etcd database to be able to perform what exactly you want to perform. Now, the main implementation of the Kubernetes API server is Kube API server. Kube API server is designed to scale horizontally. That is, it scales by deploying more instances. So you can run several instances of Kube API server and balance the traffic between those instances. So imagine that you have hundreds of nodes and thousands of people are coming in and then trying to create pod. And if you have only one API server, it will be very difficult. Some people may need to wait longer period of time to be able to get their work done. Now, if you think from that perspective of etcd and API server, they are the only friends here. etcd doesn't know anybody else beyond API server, nor anybody can interact with etcd. So that's the entry point. So you can think of it like a gateway for your Kubernetes, right? It also handles the authentication and authorization. So just in case you're not allowing anybody to interact with your Kubernetes, you have a RBAC and etc. built into it. An API server takes care of those mechanisms. So it first asks you, challenges you for the credential, and then it checks in the internal system who you are, what kind of right you have, and then it allow you to do all the other activities like modifying Kubernetes server or deleting some resources or manipulating certain things like that. So it must need to have an authentication built into the system, right? So if you do not have your user authenticated, you are simply not allowed. You can't really enter, right? Now, it is definitely a client server mechanism, right? So it basically has a watch, and that watch is deployed in multiple nodes where your actual container runs within the pod, and then they keep sending that information to the API server, right? And that watch tells you like one pod is down. Hey, what is your plan? Then API server picks it up and then decides that, hey, this node is kind of overloaded. I see there are free nodes available, so let's push this pod to the other node. So even if that pod is struggling a bit, your Kubernetes can actually make it happen so silently behind the scene and move your pod up and running in another node. You will probably not observe it if you don't uh, watch it minorly. Now, talking about the controller manager, that's also one of the Kubernetes master component. To understand controller manager, we understand that it basically component that runs the controller process, right? So logically, each controller is separate process, but to reduce complexity, they are all compiled into single binary, okay, and run in a single process. So you have many different things which runs. Some of the components we will discuss in our later slide, but understand that it's a service running inside Kubernetes master node, that is control pane. And it runs as a service, and since it is daemon is mentioned, right? So it's you see that it's a service running. Let's go deeper into that and then to understand what exactly each of these components really means. So if you see the Kubernetes controller manager, which is inside Kubernetes master component, it has got a node controller. Now, what this node controller really is, it is responsible for noticing and responding when node go down. So it checks the actual machine where your pod will be deployed, right? The health of that machine, right? And the job controller, that's the next one, which basically watches for job objects that represent one of tasks. Then create the pod to run those tasks to completion. And then comes endpoint controller. So the endpoint controller populates endpoint object that is join the services and pods. So when we go a bit deeper into pods, you will understand what is the meaning of service and how we associate the service with the pod through levels, etc. But that's the work of the endpoint controller to do that, right? The how part we'll know later, but what part is handled by endpoint controller. Now, service account and token controller create default accounts and API access token for new namespaces. So in Kubernetes world, when you deploy a pod, it needs to be deployed in a namespace. So you create a namespace, and then this will be using a token to act for that new namespace. And that namespace will host all your components like pods, deployments, services, replica set, whatnot within that namespace, right? Now, additionally, it also helps you manage the creation lifecycle of the namespace, and also does a garbage collection for the events happening there. It can actually do a lot of things in terms of the garbage collection, right? So what happens when you delete a pod, right? Because in Kubernetes, if you notice when you use the Kubernetes thing, is that if you delete a pod, it does not get deleted immediately. It has a wait period outside. That's what when the garbage collection happens via this controller manager, which is part of the Kubernetes master component. Now, one of the key component of the Kubernetes master component is kube scheduler. Now, the kube scheduler is something which watches for newly created pods with no assigned nodes. So you say Kubernetes that, hey, Kubernetes, through kubectl or kubectl, that create a pod with this container. Okay. And it says that it is successful. But at that point in time, when it says that it is successful, probably the pod is not created. It is successful in terms of saving, validating everything, like all your authentication or authorization, and saving that information into etcd database via API server, right? That's what happens, right? And this kube scheduler basically watches for those newly created pod, which has no assigned node, and select a node and run them on that node. So the factors taken into account for scheduling decision includes individual and collective resource requirement, hardware, software, policy requirement or constraints, affinity or anti-affinity specifications. If you say that I want to only deploy in this node, all this specification, or if you have, let's say, multi-container scenario, multi-pod scenario, you see that all the pods should go and live within the same node so that they can quickly interact with each other. If those are the instruction you have given in your deployment file, it will take care of that. It also will take care of the data locality, inter-workload interface, and deadlines. So many things it does take care, right? So imagine that you have got 3 nodes cluster in this picture, and then you say that my pod requests 2 GB of memory, and then that machine does not have that enough space available. They say, sorry, I can't really host you. So you go ahead and then deploy it to a different node which has got that memory available. So that's what scheduler does for us. It's a lot of background work, which otherwise we don't need to worry about being scheduler. You can run multiple schedulers in a cluster, right? It helps in many scenarios, so it quickens the activity. So those kind of large Kubernetes scenario, people often run multiple schedulers. Then after this, the core component, right? The control plane, we need to think about what actually is there in the node. We understand that node can host our container through pod, but what exactly is there in the node? Now, if you remember the first picture we showed, right, it has got a couple of things. But at the end of the day, they all need to run in each of the node you create. So when you say, hey, there is a new machine I am creating, and this is what I'm going to add it to my Kubernetes server as a node. So you need to basically install some component over there. One of the first components you need to install is Cubelet, right? That's the node component. Now, basically, it's an agent. So at the end of the day, it's an agent which runs inside that. So we'll talk about it in detail, but understand this from a Kubernetes node perspective that this is one of the key components. And then you have QProxy, container runtime, which will ensure your container is running, CAdvisor, and then obviously the pod, which is what you are creating, right? So you have got all these things running inside your node. Now talk about Cubelet, right? Which inside the node it runs, you see that it basically talks about an agent, which inside each individual node machine, either it could be a virtual machine or physical machine attached to your Kubernetes backend or cluster, need to have that, which makes sure that the containers are running in the pod, right? That's what the primary purpose of it. The kubelet basically takes a setup pod specification that you provide through various mechanisms and then ensure that the containers described in these pod specification are running and healthy. So it needs to not only ensure that they're running, but also continuously check the health status of those containers. Kubelet does not manage containers which were not created by Kubernetes. So if you go ahead and remote into a node and then say that go ahead and run a container in that node directly, you can do that because these are all at the end of the day Linux machines. So you can pretty much SSH into those machines and run a container. So if you run the container inside a node, then Kubelet is not responsible for that. It is only responsible if you create pod, and pod will run container at the end of the day. So it basically fetches the pod, not the container. Okay. But it can go up to the container level to make sure things are fine. Now, Kubelet is not a pod itself. So Kubelet itself, if you see that what all things you have inside each of the node, you will find that one of them is Kubelet, but it's not a pod. It is a service, right? So it gets this pod specification from etcd through API server, verifies their container. Like if you, let's say, do a typo inside the pod specification, the name of the container is wrong. Maybe that doesn't exist with the server you are connected to or the registry you want to pull the image from. It checks all those things. It then starts the pod using whatever controller runtime you are supporting within the Kubernetes, because Kubernetes supports multiple container runtimes. So you can choose any one of them. And then it doesn't stop over there. It keeps monitoring what is exactly happening within the Kubernetes world, right? So it is constantly observing the fact that things are happening at the back. Now, this is another key component within the node called QProxy. Now, you see that you may have one or three nodes, right? So in this picture, you see that each of them has got IP addresses assigned, and they're able to talk to each other, and then there are IP tables allocated, right? So all of them, these complex network things are happening for you. But who is behind the scene? Who is doing all these complex network things? That is QProxy. So the QProxy is a network proxy that runs on each node in your cluster. So it has to have in every node you want to attach to your Kubernetes system. And it implements part of the Kubernetes service concept, right? So you'll come a little later. But the QProxy maintains the network rules on node. So imagine that it's a network manager. These network rules allow network communication to your pod from network sessions inside or outside of your cluster. So you can actually interact with a pod from another pod, which may be in a different machine. So how do you interact with that, right? So these are the situation when QProxy comes handy, proxy, as the name suggests. And it uses the operating system packet filtering layer if there is one and it's available. Otherwise, the QProxy forwards the traffic itself, right? So it checks for if there is anything already there in the operating system. If not, then it'll go ahead and do it by itself. So it's a quite self-sufficient thing, which inside of each of the node, we need to deploy this either manually or by following the instruction. Now, coming to that QProxy component, you have the main concern of network distribution, right? And it also captures if there is any change. So for example, the pod is running in node number 1. And if by any chance the pod is down and the API server picks it up and then sends the pod into node number 2 because there is a more space available according to the pod specification. QProxy also observes those changes, makes the changes, and updates the IP table. So it need to do this kind of monitoring on a constant basis. Because API server through scheduler also doing a lot of change in the system on a constant basis, the QProxy needs to stay current with all its monitoring capability, right? Now, another thing which is absolutely important is the container runtime, because you need to understand that Kubernetes is all about running container. Okay, so you need a container runtime. Now, why not Kubernetes itself making something to run a container? Because container runtime is an open source technology. So understand that if Kubernetes puts a lot of effort on building the container runtime by itself and maintaining the Kubernetes code base will become huge, right? Instead of that, it says that, hey, let's do a plug and play mechanism. So bring your own container runtime and run it within me. So it supports some container runtime based on certain criteria. Okay. So Docker is the number one container runtime, which is by default supported within Kubernetes. But there are other container runtimes also you can choose and select if you want to, right? Now that actually reduces the responsibility of the Kubernetes overall, and then have this as a plugin component. But this is absolutely important because this is what it does at the end of the day. It needs to run container. Now, container runtime is a software. Think about it as a software that is responsible for running containers. And Kubernetes supports few container runtime like Docker, Container D, CRI-O, CRI-O, RKTLET, or Kubernetes CRI. Now, if you try to understand the Kubernetes runtime in a bit more detail, I would recommend that you go to the Kubernetes official documentation and read about the container runtimes available. I want to briefly talk about this CRI because you can see that CRI-O and container CRI is mentioned over here. What essentially CRI means is a container runtime interface. So think about it as an interface, okay, a generic layer, which consists of a specification and requirement for the container runtimes, which can integrate with the kubelet on a node, right? The CRI API currently is in alpha, okay? And the CRI Docker integration is used by default as of Kubernetes version 1.7 plus, okay? This is sort of like a generic layer which can interact with other third-party container runtimes. So you can bring your own container runtime and associate that with the Kubernetes. That's what the flexibility is, and that's why this is so important. Now, few of the container runtime, you can always go and check it out in the official documentation. Container D, CRI-O, and then Docker. Obviously, Docker is something which is mostly used scenario. Now, what is the advantage of the container runtime is mainly because it solves the primary purpose of Kubernetes, okay? And it does all the thing which container runtime needs to do to be able to run the container. Beyond that, Kubernetes will take over and then do the other stuff to make sure that the overall system is robust and up to the mark. Now, coming to the C advisor, okay, it's a Google solution. Now, what this C advisor is, it's container advisor. C stands for container. It provides container users an understanding of the resource usage and performance characteristic of their running containers. So think of it like an observer which keeps monitoring the container health, because you are running container inside a pod and it is running daemon that collects, aggregates, and process, and then export the information about running containers. So it is sort of like a service inside your machine, like antivirus service, which keeps monitoring the file changes and checks the validity of the file. Like that, it also runs as a daemon or a service inside your container to fetch about everything about the container and sends it outside, right? So it needs to export. Specifically, for each container, it keeps resource isolation parameter, historical resource usage, and histograms of complete historical resource usage. This data, which it collects, is exported by container and machine wide. And this is from Google, right? So Google built this thing. So you can imagine that it is basically quite large in terms of responsibility and things it can do, right? So it is important component within a Kubernetes environment for you to make sure that your container metrics is being sent to the kubelet, and then things happen. Okay, and that's why it knows what is to be done. It also gives you some sort of um, built-in web interface, right? Runs typically on port 4194, so you can do HTTP 4194, localhost 4194, and it'll get to see this kind of dashboard capability. You can actually access the CAdvisor of other machine, so you can fetch data from other machines, and that's how you can collect this from other things. Now, the major part of Kubernetes deployment. So when you say that I have an application and that application is containerized, okay, that's when the container comes into picture, right? Your application code is containerized. You have a container image ready already, and you want to deploy it. And you want to deploy it in Kubernetes environment. So what do? You create a pod with that container. Okay, you can have one or more containers within a pod. Once you have that, it runs on a node, actual machine, which is either a virtual machine or a machine which is physically available. And that node we sometimes call it worker machine because that's not Kubernetes master component or control plane. But it is managed by control plane, which means it keeps checking the health of the pod, etc. A pod can be deployed with other pods. So essentially a node with, depending on the size of the node, can host multiple pods. And the scheduler through the control plane handles the scheduling of the pod across the node. So which pod to run where, if there is a problem with the pod and if there is no space to spin up a new pod, they will go ahead and spin up. But at the end of the day, you don't see any difference. So you see your application is up and running. That's important. Now, this kubelet really helps you communicate between the Kubernetes control plane and the node. And this also manages the pods and container running on machines. And the container runtime ultimately pulling the container image from the registry. It could be Docker Hub or your private registry, and then does all the heavy lifting of unpackaging the container, running that, doing the lower level networking. If it is Docker, use the Docker networking component, do all those stuff. Now, if you, let's say, have a pod with a container, think about it one on one, and then you want to do a multiple deployment of the same pod. You can take an approach of deploying through deployment. So it's an object within Kubernetes, which essentially says that how many pods do you want to deploy, right? And it will basically be load balancing with your deployment mechanism. So it will have things sitting on top of it, which will load balance those pods. You can define the auto scaling capability by saying that this is the minimum number of thing I need to run. And then when things go haywire, I want to increase that thing. So this is sometimes used as the production-like environment deployment, right? So you basically say that I have a container, which is my application, and the code is running within the container. Then I define a pod which hosts that container. And then beyond that pod, I define a deployment to say what is my number of pod which will be running if it is more than one. And then what is the update mechanism? So if I have to update that, whether it will be in place upgrade or rollout upgrade, all these things taken care by the deployment. So now in a nutshell, what we understood is that the Kubernetes history a bit, and then understood the architecture of the Kubernetes, two major components, Kubernetes master component, that's your control plane, and the node component. Then we understood the pod design, right? And then we talked about the pod and its relationship with the node, and then the deployment object, which can handle multiple similar pod in a real production kind of scenario. So with this, thank you very much and see you in next lesson.